morning all. We are back with our classes on I and the colourful world. We have last part left of the chapter, which is scattering of light. Okay, it is what? Scattering of light. Yesterday and the class before, we studied first refraction through a prism. We said that the refraction through a prism basically depends on its angle of deviation. Angle of deviation is angle of incidence plus angle of emergence minus the angle of prism. We also studied dispersion through a prism, where when white light is passed through a prism, it splits into 7 different colors. This 7 different colors is the band is called as spectrum. The cause for dispersion of light was that different colors of light have different wavelength and hence they bend differently. Blue or violet has the shortest wavelength, scatters the most, bends the most, whereas red has the longest wavelength, scatters the least and bends the least. After that, we studied Newton's experiment where he took 2 prisms, one in the upright position and one inverted position, which is called as the recombinant prism, which shows that the first prism will split the light into 7 different colors, and the second prism, which is called as the recombinant prism, will combine together those 7 colors of light and bring it into a white light. We studied the optical phenomena, which is because of dispersion and refraction, called the rainbow. We said that rainbow is always seen on the opposite side of the sun. Rainbow is formed when there is enough water droplet and suddenly the sunshine comes. The water droplets present in the atmosphere act as tiny prisms and they first refract light, then disperse light, then there is total internal reflection and again refraction. Yesterday we studied atmospheric refraction. We said when light passes through different layers of atmosphere with different optical densities, it bends, due to which there are many phenomena which we see in the nature. First, the position of the star always appears to be higher. This is because the light ray which is coming from the star undergoes multiple reflections and refractions and reaches the observer on earth in a bent way. But the observer can retrace the path of light only in a straight line and hence he sees the star a little raised up. We also studied twinkling of stars. We said star is a point source of light. It is very far from the earth and when the starlight reaches the observer on earth, once maximum light reaches, once minimum light reaches and hence he gets the feeling that the star is twinkling. Whereas planet is a collection of point sources of light, it is closer to us and the amount of light reaching the observer on earth from the planet is somewhat the same. So the stars twinkle whereas planets do not. There is apparent flattening of the sun's disk during sunrise and sunset due to atmospheric refraction. The same holds good for a sunrise, an advanced sunrise and a delayed sunset. The sun which is at the furthest position near the horizon, we see the sunrise actually 2 minutes before the actual sunrise and we see the sun even 2 minutes after the actual sun had set. So the length of the day increases by how many minutes? 4 minutes. Today we have to talk about scattering of light. Okay, what do you mean by scattering of light? Scattering of light basically means that when light goes and hits any object, maybe a dust particle, maybe an atom, dust particle, some atom or any object in the surface in the traveling time, then what happens? It starts scattering light. This is what is called as scattering of light. What is scattering of light? When light in its journey hits any object, it just scatters all the lights in all different directions. Due to scattering of light, we see many optical phenomena associated. Okay, we also know that scattering of light or the intensity of light, we say generally the intensity of light is proportional to the 4th power of its wavelength. Wavelength ಗೊತ್ತು ಹೇಳ್ಕೊಟ್ಟಿದ್ದೀನಿ. So intensity of light, how strong or how powerful the colors will be, depends on what? The wavelength of light. So what is scattering of light? When light hits any object, maybe an atom, maybe a dust particle, maybe water droplet, it scatters light. So this phenomena is called as scattering of light. Now let us read about, we have studied that there are three kinds of solutions: true solution, colloidal solution and suspension. Aapka ide ninth. We have studied that when light passes through the colloidal solution, it scatters in the form of a cone, and that cone is called as Tyndall cone, and the effect is called as what effect? Tyndall effect. We have seen that in a dark room, when light enters through a small hole, the light gets illuminated in the form of a cone, isn't it? This phenomena is called as what? Tyndall effect. So the scattering of light by the colloidal particles is called as Tyndall effect. The color of the scattered light depends on the size of the colloidal particle. If the colloidal particle is very, very small, it scatters light of blue color. Shorter wavelength, so blue color. If it is slightly bigger, it scatters light of Vibgyor logic. Generally yellow to red. But if it is very big, the size of the particle, then it scatters only what light? White light. The scattering of light by the colloidal particles is called as what effect? Tyndall effect. The color of the scattered light depends upon the size of the colloidal particle. If the colloidal particle is very small in size, it will scatter violet, indigo, blue. If it is slightly bigger, it scatters light from yellow to red. And when it is very big, then it scatters only white light. Okay? So we will read this part. The interplay of light with objects around us gives rise to several spectacular phenomena in nature. The blue color of the sky, the color of water in deep sea, the reddening of sun at sunrise and sunset are some of the wonderful phenomena we are familiar with. In the previous class, we have learnt about the scattering of light by colloidal particles. The path of beam of light passing through a true solution is not visible. In differential bolidira, when you pass through true solution, the path of light is not visible, but in colloidal solution, it is visible. Tyndall effect. Albarkoli. Define Tyndall effect. Define Tyndall effect. Give two examples where Tyndall effect can be seen. Give two examples where Tyndall effect can be seen. Next, on what factor does the color of the scattered light depend? On what factor does the color of the scattered light depend? On what factor does the color of scattered light depend? These are three questions from this part or from this paragraph. Let us read through it. The Earth's atmosphere is a heterogeneous mixture of minute particles. These particles include smoke, tiny water droplet, suspended particles of dust, and molecules of air. When a beam of light strikes such fine particle, the path of beam becomes visible. The light reaches us after being reflected diffusely by these particles. Please underline, the phenomena of scattering of light by the colloidal particles give rise to Tyndall effect. So what is Tyndall effect? The scattering of light by colloidal particles is called as what effect? Tyndall effect. Example, it is seen when a fine beam of sunlight enters a smoke-filled room through a small hole. First example. Second example, it can also be observed observed when sunlight passes through a canopy of dense forest where tiny water droplets in the mist scatter light. Both examples clear? When light enters through a small hole in a dark room, or when sunlight enters in a dense forest through a thick canopy of trees. Okay. Third question, underline please. The color of the scattered light depends on the size of the scattering particle. Very fine particles scatter blue light if the size of the scattering particle, while larger particles scatter light of longer wavelength. If the size of the scattering particle is large enough, then the scattered light may only appear white. Clear what you have written? So, what did we study? We studied that the scattering of light by colloidal particle is called as what effect? Tyndall effect. We can see Tyndall effect at two cases. That is, when the scattering light enters, or when white light enters a thick canopy of forest or a dense forest or a thick canopy of trees, or when white light enters through a small hole in a dark room. The color of the particles depends upon the size of the particles. Very small particles scatter blue light. Particles of a larger wavelength or particles of a larger size scatter wavelengths which are longer. And if it is very large, it scatters only white light. Now, let us go to the next one. Why is the color of the sky blue? Very, very important 2-mark question. Very important 2-mark question. New book also the same thing, no? Or something has changed? Same thing. Okay, so now let us understand why do we see the color of the sky blue. There are few very intelligent kids who will say because it is a reflection of the ocean. Okay, so that means in Rajasthan the color should look brown. We don't get something like that. There are very great people whom I have taught who will say wonderful things. Okay, so as a result of it, remember, color of the sky is blue because when sunlight reaches the earth's surface or when sunlight reaches the earth, it gets scattered. A part of the light gets scattered. So what happens is the longer wavelength of the light do not get scattered easily. The shorter wavelengths of the light get scattered easily, and hence we see what? Blue, because blue has shorter wavelength and it scatters the most. When I go up in the atmosphere, that is when I'm flying basically, I do not see my sky as blue. I see it as grey or black in color. This is because there is no atmosphere at higher altitude and the scattering is very, very less. So we do not see the color of the sky as blue. So let us read through it. The molecules of air and other fine particles in the atmosphere have size smaller than the wavelength of visible light. They are more effective in scattering light of shorter wavelength at the blue end than the light of the longer wavelength at the red end. The red light has a wavelength about 1.8 times greater than the blue light. Thus, when sunlight passes through the atmosphere, the fine particles in the air scatter the blue color more strongly than red. The scattered blue light enters our eye. This is your answer for why does the sky appear blue. Because we have particles in the air, in the atmosphere, which have a size smaller than the wavelength of visible light. Chota particle will scatter shorter wavelength and hence it will always be what in color? Blue in color. If Earth had no atmosphere, there would not have been any scattering. Then the sky would have looked dark. Please write a question. Why does the sky appear dark? Why does the sky appear dark to passengers? Why does the sky appear dark to passengers flying at higher altitude? Flying at higher altitude. Why does the sky appear dark to passengers flying at high altitude? What happens? At higher altitude, the atmosphere is very, very thin, or there is no atmosphere. So there is no scattering of light. Please underline that line. The sky appears dark to passengers flying at very high altitude as scattering is not prominent at such heights. Why is scattering not prominent? Because the atmosphere is very, very thin. Okay? Please write next question. Why are danger signals painted red? Why are danger signals painted red? Why are danger signals painted red? The best answer, I'll tell you from one of them, because red signifies blood. So if you're going to die, blood is going to come out. So that is why danger signals are painted red. Somebody great from St. Joseph's only. Okay. So basically, why are danger signals painted red is because red has longest wavelength and it scatters the least. So even from a very far distance, you should be able to identify the signal. Okay, that you should not go this side or that side, or it is a danger in front, or the road is under repair. All that is always painted in red, because even in the night, the red light does not scatter most, and whatever is written can be easily read and understood. Clear? Answer. The red is least scattered by fog or snake. Can you see? The red is least scattered by fog or smoke. Adrinda munche one line barkondbidi. A red light has a longer wavelength, or has the longest wavelength, and scatters the least. Red light has longest wavelength and scatter the least. It can be seen even during fog or smoke. It can be seen in the same color at a distance. Underline there only. It can be seen in the same color at a distance. And hence, danger signals are painted red. Clear all the three questions in this part. The first part was what? Why is the color of the sky blue? The atmosphere has particles which are shorter or which are smaller than the wavelength of visible light. These particles, which are smaller in size, will always scatter light of shorter wavelength, and hence we see the blue color of the light. At higher altitude, the color of the sky is not blue, it is dark grey or black, because what is not predominant? Scattering is not predominant at such heights. That means scattering does not take place as the layer of the atmosphere is very thin, or there is no atmosphere. Danger signals are painted red because red light has the longest wavelength. It scatters the least. It can be seen through fog or smoke. It can be seen in the same color through a very large distance, and hence they are painted red. Next question. Why is the color of the sun at sunrise and sunset red? Red or orange, whatever you draw in sceneries there. Okay. Why is the color of the sun at sunrise and sunset red in color, or is red? Fine. So we have seen not maximum times the sun appears red, but the sky around the sun completely appears what? Reddish orange. So let us understand why. See, when the sunlight is reaching the earth, all the shorter particles or the smaller particles, they will scatter what light? Blue light. So the sky appears blue. But the sun is at the farthest distance from the observer on earth, and all the shorter wavelength of lights are already scattered. So what reaches the observer on earth when he focuses at the sun? longer wavelength of light. What are the longer wavelength of light? Yellow, orange, red. And hence we see the sun orangish red. Understood? Because the sun is at the farthest distance. The sun is somewhere near the horizon, which is very far for the observer. And only the longer wavelengths of light reach the observer on earth. So what are the longer wavelengths of light? Orange and red. And hence the sun appears to be what? Orange red in color. Idella scattering only two logic. What is the logic? Small size, shorter wavelength, blue light. Large size of the particle, large distance, longer wavelength, red light. Okay? So let us read through it. Let us do the activity to understand the blue color of the sky and the reddish appearance of the sun at sunrise or sunset. Next page. See the second paragraph. Light from the sun near the horizon passes through thicker layers of air and larger distance in the Earth's atmosphere before reaching our eyes. So longer wavelengths of light, so that is orange and red. However, light from the sun overhead would travel relatively shorter distance. At noon, the sun appears white. Please underline. What is the color of the sun at noon? At noon, the sun appears white as only a little of blue and violet colors are scattered. Near the horizon, most of the blue light and shorter wavelength are scattered away. Therefore, the light that reaches our eyes is of longer wavelength. This gives the reddish appearance of the sun. Answer gottaito? So this part you please write, underline. At noon, the sun appears white, as only a little of blue and violet lights are scattered. This is the answer for why does the sun appear red. Near the horizon, most of the blue light and shorter wavelengths are scattered away by particles. Therefore, the light that reaches us is a longer wavelength. This gives the reddish appearance of the sun. Fine. So the color of sun during noon, white. During morning and during setting time, it is orange red in color, because it is at the farthest distance from the observer on earth. So longer wavelengths of light reach the observer on earth. Hence it is what in color? Reddish orange in color. This is an activity to prove. Please write our activity 11.3. Prove by an activity. Prove by an activity that blue has shorter wavelength and scatters the most. Blue has shorter wavelength and scatters the most, and red has longer wavelength and scatters the least. Red has longer wavelength and scatters the least. Red has longer wavelength and scatters the least. Okay? Very important activity, comes for 3 marks in board with the diagram. So figure 11.11 important. Figure 11.12 also important. You have to draw. That is for the red color of the sky at sunrise and sunset. Okay, see, you can see you just follow the diagram along with me. What are we doing here is, we basically are trying to find out the scattering of light by colloidal particle. So first thing what we do is, we take a source of light from where there is many light source coming. We place a convex lens because it converges the beam of light. Okay, and then what we have placed with the convex lens is a tank which has got nothing but white or water in it initially. Okay, and then besides it I have placed a cardboard, and this cardboard cardboard has got an opening only at the center. So what it does, it will actually focus all the ray of light which will fall on another convex lens, and a screen is placed at the focus of this convex lens. Understood? So we have taken how many lenses? L1 and L2. Two convex lens. We have a source of light. We have a glass tank which contains some water. And we have a cardboard which will intensify the beam of light, because only the light which passes through the center will fall on this convex lens, whose focus we have kept a screen. Okay. Now what we have to do? When actually there is no substance dissolved in it, the light will be just allowed to pass through it. You cannot see the passage of light, but you will see that the light is passing through it and nothing is found on the screen. Okay. Now, after that, what we do is, we add to it 200 grams of sodium thiosulfate. In water only, I add what? 200 grams of sodium thiosulfate. What is sodium thiosulfate? Na2S2O7. So this is sodium thiosulfate. Okay, so we basically add to it, in water, we add 200 grams of sodium thiosulfate. When I add to it 200 grams of sodium thiosulfate, immediately there is formation of colloidal sulfur. What happens is, the moment I add to it, I will get what sulfur? Colloidal sulfur. Now this colloidal particle, it has to scatter light. So what happens is, the colloidal particles first are very small in size. So what happens when these particles scatter light? This area, and the behind part of the tank, it starts appearing what in color? Bluish in color. Because these particles will first scatter light of shorter wavelength. The shorter wavelength is violet, indigo and blue, which we easily cannot differentiate. So we say this and the behind side will become what in color? Blue in color. The larger colloidal particles will scatter light of longer wavelength, which passes through this, falls on this, and finally it will come and show a reddish orange spot on the screen, which shows that the light of larger wavelength or longer wavelength scatter the least, and it has the longest wavelength and hence makes its appearance on the screen by traveling a longer distance. Is it clear? Innonsari. First, take a source of light, take a convex lens, take a tank from where we are actually filling it up with water. Take a cardboard to intensify the parallel beam of light, another lens L2 and a screen. After that, dissolve 200 grams of sodium thiosulfate in it. When you dissolve, you will have what sulfur? Colloidal sulfur. Colloidal sulfur is particles which will be bigger in size. Okay, these particles will start scattering light. First, they will scatter light of shorter wavelength. So this part of the tank appears what in color? Blue in color. But if you leave the experiment for some time, after some time, you will find that on the screen there is a reddish orange color. This is because red light gets scattered by colloidal particles which travel a longer distance and make its appearance on the screen, which proves red has longer wavelength and blue has shorter wavelength. Okay, so we will read through it. Place a strong source of light at the focus of a converging lens L1. This lens provides a parallel beam of light. Allow the light to pass through a transparent glass tank containing clear water. Allow the beam of light to pass through a circular hole made in the cardboard. Using a second converging lens, make a sharp image. Dissolve about 200 grams of sodium thiosulfate in about 2 liters of clean water taken in the tank. Add about 1 to 2 ml of 1 to 2 ml of concentrated sulfuric acid. When you do that, what will happen? Colloidal sulfur will be formed. You will find fine microscopic sulfur particles precipitating in about 2 to 3 minutes. As the sulfur particles begin to form, you can observe blue light from the 3 sides of the glass tank. This is due to the scattering of short wavelength by minute colloidal particles. Observe the color of the transmitted light from the 4th side of the glass tank facing the circular hole. It is interesting to observe at first the orange-red color and then a bright crimson-red color appears on the screen. This proves that blue has what wavelength? Shorter wavelength, and red has longer wavelength. Clear? This finishes your chapter. Nothing else from this chapter. Go back from 1st to 8th. It is not there. Exercise question from 1 to 8 is not there. Even 9th is not there. Why do stars twinkle? Taught. Why? Explain why planets do not twinkle? Taught. Why does the sun appear reddish early in the morning? Taught. That diagram, last diagram, figure 11 point something, 11.12. Why does the sky appears dark instead of blue to an astronaut? Because at higher altitude, scattering is not predominant. Okay, so I will send you the notes today without fail, and from tomorrow we will start with, shall I do biology or shall I finish chemistry? Okay, you take a vote tomorrow, fine? Or if you, because we have only 1 chapter of chemistry left, 1 chapter of physics left, and 2 chapters of bio left. Bio can be done at Aram se. So I think after I finish 1 more chapter, then I will start taking classes only 2 days a week. Then also we will finish. Okay, sure. All the best.